Intermediate Algebra for Statistics, Function Problems, Part 3. Is this relation a function? The answer is yes. It passes the vertical line test. Number 1, what is f of negative 1? What is the value of y when x is a negative 1? We see that that is positive 2. Number 2, what is f of positive 1 when x is 1, y is 3? Number 3, what's f of 5? We gotta go x, 1, 2, 3, 4, 5. Put a dot, and it appears to be 2. So f of 5 equals 2. Number 4, what is the value of x when f of x is 0? F of x is 0 is right here. It's only intersecting one spot, and that is when x is equal to 3. Number 5, what is the domain? And that question is asking what are the possible x values on this graph. Okay, we have an arrow to the left, so we do not have a minimum. This is going from negative infinity, and let's keep going, and now we have an arrow on the right hand side, and that's going to positive infinity. So we say all real numbers. There is a symbol for that. It is capital R, fancy R, and that's short for all real numbers. In set notation, we do parentheses because we can never equal infinity or negative infinity. We start with the smallest value, negative infinity, comma, to positive infinity. And again a parenthesis because we can't ever reach infinity, equal infinity. So the domain is all real numbers. Number 6, what is the range? So we go to the y-axis and we want to know what are the possible y values for this graph. We do have a minimum. It's at 0. So from 0 up to a maximum, we see the maximum is occurring at 3. So all possible y values would range from 0 to 3. It can equal 0, as it does here, and it can equal 3. So it's all numbers between 0 and 3. And they can equal, so we do this, in set notation, bracket 0, comma 3, bracket. Number 7, what is the maximum? That means the maximum y value, and that is 3. Number 8, what is the minimum? And we see that is when f of x is equal to 0. Where is f of x increasing? Well, that is asking where the slope is positive. So from this point here, the slope is 0. So from this point to this point, we have a positive slope. This is decreasing, and this blue part is increasing. So we have two sections from 0 to a positive 1. When x is in between 0 and 1, the function's increasing. And from 3 to positive infinity. Again, we don't have to worry about equals to's here because you can't increase at a point. Now another way of writing this is saying 3 is less than x, which is less than infinity. Everything's less than positive infinity. So another way we could write this is simply saying x is greater than 3. So our answer is all numbers in between 0 and 1 and numbers greater than 3. Number 10, where is f of x decreasing? One location from this peak down to the minimum. That slope is negative. So we say from 1 to 3. And set notation, this would be parenthesis 1, 3. Number 11, where is the rate of change equal to 0? That is asking where is the slope 0? And that's in this area right here. So from negative infinity all the way up to 0. Now again, another way of writing this, x is less than 0. These two statements are equivalent. If we write this in set notation, we would start off with our minimum, which is negative infinity. That's a parenthesis because we can never equal negative infinity. Going up to the largest, which is 0. It doesn't equal 0, so we put a parenthesis. So any one of these three notations will work. Number 12, where is f of x positive? So that's in quadrant 1 and 2. So anything above the x axis, f of x is going to be positive, y is going to be positive. That works for every single x except for 1. And that would be when x does not equal 3. Because when x equals 3, y is 0. And when y is 0, it's not positive, because 0 is not positive or negative. So we could say all real numbers except when x does not equal 3. And this is the shorthand for that. So this implies all real numbers except for 3. Number 13, where is f of x negative? That's in quadrant 3 and 4. So anything below the x-axis, f of x is going to be negative. We don't have anything below the x-axis. So the answer to 13 is there is none. It's the empty set. Number 14, what are the x-intercepts? We have 1 here, and that happens when x is equal to 3. Number 15, what are the y-intercepts? We only have 1, of course, and that's when y, or f of x, is equal to 2. And we could write this as an ordered pair, or we could simply make this statement. Thanks for watching.